So, okay, I'll go ahead and tell you a little bit about myself. Well, are you guys all from Florida?
Yes.
I'm from Chicago.
You're from Chicago, the Windy City.
Yep.
Okay.
But we haven't told them, Greg, we haven't told them yet why Chicago's the Windy City, so don't give it away, okay?
Okay, I'll try not to.
Okay, good.
Yeah, so anyways, you're right, I'm getting a PhD right now. And what happened was that I started off at a young age really liking weather. And I grew up in South Texas, and every spring my parents would drive me and my sisters all the way up to Fort Worth. And so I would get to see a lot of the summertime storms there. And then also living near South Texas, we saw a lot of hurricanes, or not a lot of hurricanes, but we tracked a lot of hurricanes that would go through the Gulf, and we wanted to make sure that they didn't come and hit us. So that's where a lot of my interests in meteorology came from. And when I was in third grade, I moved to Maryland and started going to school there with my family. And so there I got to experience things like snowstorms and actually hurricanes as well, and tornadoes. And then later on, when I was in high school, I was trying to figure out what I wanted to go to college for, and I remembered a lot about my love for meteorology, because probably like you guys, have you guys picked up all sorts of weather books at times?
Mm-hmm. Yes.
Yeah.
Yeah. So I was a lot like that, and I would read these books, and I would really, really like what was in them, and I liked the way that the atmosphere worked, and it was all so different all the time. And so I said, I'm going to go and study meteorology. And there were a whole bunch of colleges that I looked at. I looked at places like the University of Maryland. We went to go visit schools. We went to go to Millersville. But one school that I went to was called the University of Oklahoma. And I can show you the building that I work in right here. So this is the building that I work in, called the National Weather Center. And I'll try not to drop my laptop. We have this big atrium that we work in.
Whoa.
And so all of the different people on these floors do different things. And this building and the people in it that I got to speak to when I came to visit Oklahoma really helped me decide that I wanted to go here. And so I did my undergraduate here, which lasts for 4 years. And then I did my master's, which is basically a degree that you learn a lot more about meteorology in depth and you do a little bit of research. And then now I'm doing a PhD, which means that I'm actually trying to create my own area of research about meteorology. So that's kind of my story. And one of the things that I did in high school was I worked with Mike Mogul as an internship. And then after high school, I continued to work with him, working at weather camps like the one that you guys are at. And I'm actually very happy I get to talk to you guys, because I miss being able to do this. Since I've gone into graduate school, I can't participate in weather camps nearly as much as I would like. So do you guys have any questions for me?
No. Yes. Do you, what's your favorite kind of meteorology? Tornadoes, hurricanes?
Well, it depends upon the time of the year, but since I've come to Oklahoma, I've really started to like storms, especially supercell thunderstorms. You guys studied those yet?
Thunderstorms, yeah, we studied them today.
Yeah.
What about a particular type called supercells?
Yes.
Yes?
We haven't done supercells in depth yet.
Okay. Well, supercells are a particular type of thunderstorm that are especially long-lived because they actually rotate. And these types of storms are actually storms that produce tornadoes a lot more than any other type of storm. And that's usually because they rotate. And so it's really quite cool. Ever since I've been living here, I get to go and I see these storms, and you can look these up on Google. But you see these storms that appear in the middle of the sky, and there's this huge anvil cloud, and then when you look at the actual updraft of the storm, where all the air is going straight up into the atmosphere from the ground, that updraft looks like a UFO or a wedding cake. It's very smooth on the outside, and that's partially because it's rotating. So I especially like thunderstorms, and that's actually a component of my research these days. So have you guys experienced a lot of thunderstorms? Well, yeah, you guys experienced a lot of thunderstorms in Florida, right?
Yeah. We're sort of in one right now.
Okay.
Not sort of. We are.
We are now.
It's been
So what have
thundering
you
for
guys
half an
learned
hour.
about thunderstorms in Florida.
You guys have learned about the sea breeze.
Yeah.
Tell Greg about the sea breeze.
How long do the thunderstorms in Florida usually last?
30 minutes.
30 minutes at most.
30 minutes.
30 minutes to 45.
So what your observations there have told you is something very similar to what I do here. So often what I have to do is I have to think about how long things last, or I observe how long they last. And then based upon how long they last, I can deduce things about what sort of processes in the atmosphere might be contributing to how long those things last. So for example, the 30 minutes, that's roughly the amount of time that it takes for air to travel all the way up to the top of the atmosphere and come back down. To connect it to the supercells that I mentioned, the supercells, they can last several hours. They can last probably like 6 hours or something like that. And so there must be something else happening with those storms as opposed to the regular thunderstorms that you get in Florida. So in a way, and this is something that I really like about severe weather, and you guys can think about, is how long do things last, and maybe what sort of environment is different between these different storms, and how long they may last. I know we went on a bit of a tangent there.
No, but we'll put it on the question board, Greg. That's a good point.
Okay. So what else have you guys observed in weather camp so far?
Come on, guys. You learned a bunch of stuff. Don't fail me.
What a.
Well, we're making a balloon right now.
Uh-huh.
What kind of balloon?
Weather balloon.
Not a weather balloon.
Ish.
Weather balloon-ish? No, what type of
Yeah,
balloon is it? What are we going to do with it? How are we going to get it to fly?
Hot air balloon.
Hot air balloon.
Yeah.
So they're doing the hot air balloons, Greg.
Okay.
Come on, what else have you guys learned?
Wait.
Clouds, the rotation
Don't
of
forget how
the
to
northern
say it.
hemisphere and the southern hemisphere, how they spin counterclockwise and clockwise.
Okay, Gillette, what's something you learned?
The types of clouds.
Okay. Garrett?
Mass, like solid, liquid, and gas.
Okay, the water cycle and the 3 types of phases.
What a no fellow Kakaji is.
Oh, I love that.
All right.
Nephelokakajia.
Isn't that a great word?
Yeah.
You know what's even better, Greg? We
What?
went outside and we cloud watched yesterday right after we learned the Nephelokakajia,
Uh-huh.
and we got to see an elephant cloud,
Oh, man, that's great.
trunk and all.
I love the fellow. Yeah, you can do that with all sorts of
It's
things.
a great word for hangman.
Yes, it is.
Yes, it is. So do you guys have any questions about maybe severe weather here and what I do here exactly?
How typical do you get derechos?
Oh, that's a good question. So it depends upon how you define that. In Oklahoma, we don't get them nearly as much as you get maybe up near Chicago Ohio, sort of the West Virginia, Midwest area. I mean, we experience a lot of patterns here that could form those. And usually what happens is that in the summertime, we get a lot of thunderstorms that develop near Colorado. Do you guys have a map in front of you?
No, but we can do that pretty quickly,
No.
Okay.
because we have a map here. And here's Oklahoma down here where it says 71. And here's Colorado where it says 43.
Was it
So, go ahead.
was it hard finding colleges for weather?
No, not necessarily. It helps to know people, like Mike or myself. Let me go back to the derecho question. So, in the summertime, there's a very big pattern that usually likes to set up. And that's where you get a lot of thunderstorms that form in western Colorado or Kansas or eastern Colorado, western Kansas, near western Nebraska. And those storms like to congeal into larger storms, and they progress eastward, usually. So they go through Nebraska, maybe Iowa, and then past Illinois. And those are the typical patterns that you have for derechos, because they are basically long-lived complexes or areas where you have thunderstorms that continually regenerate. So you can think about the atmosphere in terms of building blocks. So you guys have already observed a lot of the really basic building blocks. So that's basically the outside thunderstorm where air goes up and it comes back down. Okay? Well, you can also think about ways that the atmosphere could set up areas where you continually send up air, or you can think about like hot air balloons of air, and they continually go up to the top and come back down. And that's usually how these derechos form, is you have something in the environment that's different that allows that to happen.
Now, I think we should tell Greg. Greg, I'm going to interrupt for a second just so you know the age group of these kids. You might not know it. I don't know if Matt told you. Don't want you to get too far over the head with them. But
Yeah.
3 of the kids are going into 6th grade next year. And one of them is going into 9th grade. But they all have an interest in weather.
Okay.
So there's nobody here that does not have an interest of sorts in weather.
Weather's my passion.
Okay.
Okay, some of them watch the Weather Channel 27/7. That was a joke.
It wasn't.
Yeah, I got it.
Okay, all the kids didn't. They're all staring at me like, huh? But they are weather Trekkies, and they've been good observers and good collaborators working on all the projects and everything together. So, but I just wanted you to know what their ages were, so you didn't get too deep into the derechos, even though they're interested in them.
Yeah. A lot of so you guys have a lot of questions, or you can probably have a lot of questions, and a lot of what you can do to try and come up with ideas about how to answer those questions yourself is basically by applying the scientific methods that you've learned in school. You know, you guys right now are outside taking observations, and then you come up with some sort of explanation for why things happen the way they happen.
And even if it's wrong, it's still okay to come up with a reason for why you think something happens.
Absolutely. As a researcher, that's essentially my job, is to come up with reasons. And my job is not necessarily to come up with reasons, but it is to test those reasons. So if I have an idea of why the atmosphere does something the way it does, then I have to test it. And I have to test it so many different ways in order to try and disprove that idea. So if I say that, for example, that thunderstorms are caused by birds flapping their wings, then I have to come up with some sort of experiment to test that. Does that make sense?
Yes.
And in a way, all sorts of meteorologists have to do that. Forecasters have to do that. Researchers have to do that.
Even people running weather camps have to do that when we try experiments and they sometimes don't work the right way.
Absolutely. Absolutely.
Does he know your first H initial?
He does, but if he tells you my first H initial, he's toast. They want to know what the H stands for, Greg. Don't tell them.
Oh. What do you think it stands for?
Hendrick.
Howard, High, Huffing Horse,
I personally like Huffing Horse. I think that's a pretty good one.
Hurricane,
Hendrick.
I like hurricane.
There's a guy down in South Texas in Laredo. His name is Heatwave. That's his nickname because he likes to study heat waves down there.
Wow. I didn't know that.
Yeah, I like hurricane much better.
Yeah. Hurricane Mike Mogul.
That's a good one.
Yeah, I like that.
Okay. Well, I told them I would tell them what the H stands for, but not till the end of the week. I want to keep them guessing.
Yeah.
have we got it right yet or no?
I'm not telling.
Oh.
No, why can't you just tell us if we got it right?
So, Greg, let me throw a couple other things out there to get back on track here. So, one of the things you said was that you have to do a lot of testing to prove something is true. But I think that we learned this in geometry class in high school, that it's easier to prove something is false than it is to prove something is always true.
That's exactly right.
And the reason is that if you have to prove something is always true, you have to prove it under every single circumstance that it's true. If I want to prove it's false, all I need is one example that it doesn't work, and it's false. So it's a lot easier to prove things false than true, and if you two guys will stop that, I would be much happier. Tom, thank you.
That's exactly right.
So
I mean,
now
think
we've
about-
given them a little bit of insight into geometry when they get to geometry class.
So in meteorology, we have to use a lot of different math concepts, like geometry and algebra and calculus.
Ooh, math! Ooh! I'm
None
just
of you
kidding.
guys like math. Some of you guys do.
Two of them do. Two of them are coping with it. We're going to show them some shortcuts, though, before the week is out, I promised.
There are things about math that I don't like too, and things that I'm not as good at with math than I am